Hello and welcome. I'm Ben from Digi Technical Support. In this video I'm going to show you how to use iptables NETMAP function to translate IP networks on a Digi Accelerated Linux Router. For this demo I'm using the TX54 and IX20, both running firmware version 22.11.48.10. First of all, let me show you the lab that we're using and the scenario. So let's say we have an existing HQ network that's using multiple IP address ranges. So you can see there's a layer 2 network straight off the WAN router, 172.17.20.0 with a /24 network. And there's also a layer 3 switch running some other subnets which are utilizing the 192.168.16 through to 31 ranges, or with 24-bit masks. Everything's working perfectly well, and there's routing between all the networks that are there. Imagine now that the HQ takes over another site, and they need to have remote connectivity between the two sites. The problem here is that the remote site, it's quite large, and there's a lot of users and PCs on that network, but the LAN addressing in use on the new site overlaps with one of the network ranges in use at the HQ site. So you can see here that the remote network is 192.168.22.0/24, and that overlaps with one of the networks already configured on the HQ side. Now typically what you would do to connect the HQ site and the remote site would be to build a VPN to secure the communications between them. So let's assume the network admin has built a VPN, and the traffic selectors for the VPN routing are 172.17.20.0/24 on the HQ side and 192.168.22.0/24 on the remote network side. Now this VPN will come up, but you're going to encounter some problems when trying to send traffic over it. For example, HQ-PC1, if that tries to send data through to site A PC1, the packet will go from HQ-PC1 through the layer 2 switch and into the router LAN 1 interface. From there, the routing table will direct the traffic out of LAN 2 up to the layer 3 switch and then into the corresponding layer 2 switch for that network. The traffic will never go over the VPN to the remote network. Now let's look at it from the other side. Site A PC1 wants to send traffic through to HQ PC1. The packet goes from Site A PC1 into the layer 2 switch and then into the WAN router for the remote site. The packet goes over the VPN, arrives at the HQ router. The packet is forwarded through the layer 2 switch and onto HQ PC1. All well and good. However, the reply packet is going to have the same problem. The reply packet is going to go from HQ PC1 into the layer 2 switch into the router. At that point, the packet's going to get directed out of the LAN 2 interface up to the layer 3 switch and out through the corresponding layer 2 switch onto that network. So the question is, how do we get round this? First of all, let's simplify the diagram. Now, I know what you're probably thinking. Why doesn't the admin of the remote site just go and use a new range that's outside the HQ ranges? Well, sometimes it's not that easy. Sometimes remote sites don't have a dedicated IT person, so you have to get someone to go out there. You turn up at the site and you find that various devices need certain IP addresses on that network. Reconfiguring the whole network is going to be a real pain for the IT administrator. And we can do this much easier with a simple workaround. Yes, it's not great, it's a bit of a sticking plaster, but it works perfectly well and lots of people do this. So what we're going to do in this scenario is we're going to make a modification to the VPN traffic selectors and bring in the NETMAP functions. The first thing that we need to change is the remote site IP addressing. And for this we use a fake subnet within the IPsec traffic selectors. So instead of it being 192.168.22.0/24, we're going to change it for something that's not currently in use on either side. So for this demo, we're going to use 10.10.10.0/24 as the fake VPN subnet. We're then going to configure the NETMAP function within iptables to do a one-to-one network translation. This means that traffic coming from the HQ PC1 will need to be directed to 10.10.10.2 to reach the Site A PC1, and it's only the first 3 octets that get translated. Right, Let's have a quick look through the configuration on both routers, and this is prior to making the changes for NETMAP. So we've got the remote site router on the left, that's the TX54, and the HQ side router on the right, that's the IX20. First of all, the LAN side interfaces. This is the local network. HQ side 172.17.21/24, and the remote network side 192.168.22.1/24. And then into the VPN configuration. This is just a plain IPsec VPN in tunnel mode using ESP protocol. The authentication method is pre-shared key, and I've added a pre-shared key on both sides that matches. The local IPsec endpoint is the default route interface, and the IPsec ID is set to the WAN interface IP address. This is just standard for any main mode VPN. The remote endpoint is the other side's router's WAN interface IP address, and the ID in use is the IPv4 address again, and that's of the other side's WAN interface. And now to the traffic select policy. You can see here that on both sides the local traffic selector is set to custom network, and the network range is set to the IP network configured on either side. I've used the custom network option because this ensures that the VPN remains up even if the connected LAN interface goes down for any reason. The remote traffic selector is the other side router's network that you're going to be routing traffic through to. Scrolling down into the proposal section, you can see that this is an IKEv2 VPN, and the phase 1 proposals match on both sides: Triple Des, SHA-1, Diffie-Hellman Group 14. And the phase 2 proposals also match: Triple Des, SHA-1, Diffie-Hellman Group 14 on both sides. Okay, let's go back to the live routers. The TX54 on the left is for the remote site, and the IX20 on the right tab is for the HQ site. The first thing I need to do on both is go into System Device Configuration. And now we need to change the VPN configuration on both sides. So on the TX54, I need to change the local traffic selector to 10.10.10.0/24, and on the IX20 HQ side, I need to change the remote traffic selector to 10.10.0/24. So I can apply those changes. And that's all the configuration I'm going to be doing on the IX20 side. So let's close up the VPN section and go into Firewall, Custom Rules. The rule that's there at the moment, you can ignore that. This is just a quick way for me to access the TX54 on its WAN interface. We need to add 2 rules into here to perform the NETMAP functions. So the rules that you need to add are iptables, and we're going to affect the NAT table, so -t to specify the table, and then -i to insert at the top of the chain that we specify. And for the first chain, we're going to specify the pre-routing chain. The inbound interface, so -i, we're going to specify IPsec _, and then we need the name of the IPsec VPN that is configured. So going back into VPN IPsec tunnels, this one is called VPN1. So I need to add that here. Note this is all case sensitive. Next, we need to specify the destination, because this is the destination before the NETMAP function has happened. So we're going to say 10.10.10.0/24, because this is traffic that's coming in over the VPN into the TX54, and we're going to jump that to the NETMAP function and NETMAP that to the real network address 192.168.22.0/24. So that's affecting traffic coming into the TX54 over the VPN. The next rule that we need to add is for traffic going out over the VPN to the HQ site. So again, iptables -t, we're going to affect the NAT table, minus capital I to insert into the top of the chain, and we want to insert into the post routing chain this time. Instead of being the inbound direction, this time it's the outbound direction, so that's -O for outbound. Again, enter the IPsec _ VPN1 name to specify the VPN tunnel name, and then specify the source address that needs to have the NETMAP function applied to it. So that's 192.168.22.0/24. And we're going to jump that to the NETMAP function, and we're going to NETMAP that to 10.10.10.0/24. And those are the two rules we need. One affecting traffic coming inbound over the VPN, and one affecting traffic going outbound over the VPN. Let's apply those changes. So we've configured the IPsec traffic selectors, and we've also configured NETMAP to do some translation. So what you will find now is that packets will be able to go from site A PC1 all the way through to HQ PC1, and reply traffic will come back correctly. That is all working with this configuration. What won't be working is HQ PC1 won't be able to initiate traffic to site A PC1. You will end up with packets going missing, and you will see all sorts of errors if you try and trace this, because it thinks 10.10.10.0 is going to be available via the default route, which is the WAN 1 interface. So to get around this, we need to add in a static route to say that 10.10.10.0 is available via the LAN 1 interface. To do this, we go into Network, Routes, Static Routes, and press on Add. So we're going to say that the name is fake 10.10.10.0/24 is LAN 1. The destination 10.10.10.0/24, and the interface is LAN 1. We don't need to put in a gateway address, we just need to say that this range is available via LAN 1. And apply that. Let's have a quick status check of the VPN and just make sure everything is up, and you can see that the VPN is up. The TX54 side, local network 10.10.10.0, and the remote network 172.17.20. So that all looks good. And now finally to test. I should be able to ping the remote PC. This is in the HQ network, so that will be 172.17.20.2. And we can see there we've got replies. And also if I do a trace route to the same address, 17.20.2, we can see it goes to the VPN router first. That's the remote site TX54 over the VPN to 172.17.20.1. That's the other side of the VPN, that's the router, and then onto the PC at the remote HQ. And we get the replies. So we've got proof there that the solution is working. And finally, we can use TCP dump on the TX54 router to have a look at the network translation that's happening in real time. So I've opened up a shell session onto the TX54, and I'm going to run a TCP dump command to start capturing traffic. We're going to say -I any interface. We don't want to resolve IP addresses. We're going to have a bit of verbosity. We're going to capture on ICMP and host, which is going to be the other laptop on the HQ side, 172.17.20.2. And if I bring back up the command window, send one ping, and we can see that the top line is the packet coming in on Ethernet 2. It's going from the PC I've got connected here. It's actually got the IP address 192.168.22.184, not .2 as in the diagram, but it's still within the same network. And it's going through to 172.17.20.2, which is the PC one on the other side of the VPN. Then we see the packet going out on IPsec, and the NETMAP translation has happened. The new address is 10.10.10.184, so the first 3 octets have been translated, and the destination remains the same. The packet that we see next is coming in on the VPN, and it's coming from 172.17.22 through to 10.10.10.184, which is my laptop, and that gets translated to 172.17.22, still remaining as the original source address, but the new destination ends up being 192.168.22.184, and that's going out on Ethernet 2. Ignore this line about Ethernet 0, it's just the way things are configured and the tracing is happening. So it's the first 4 lines that you're interested in. The packet coming in on Ethernet 2, going out on the VPN, coming back in on the VPN, and then going out on Ethernet 2, and NETMAP performing its functions very well. If you need any more information about this or any other feature of your Digi router, see the support pages at digi.com/support. I hope you found this useful, and thank you for watching.